Hello, everyone, and thank you for joining us today for a learning and growing webinar, the Polyparadigm Competency-focused learning on learning in online mathematics curriculum. Our presenter today is Pascal Ruides of Broward University College. My name is Sidra, and I'm a moderator for Hawks Learning. We will have a live Q&A session after the presentation, so please enter any questions you have into the Q&A module as we go, and we'll be sure to answer them at the end. I'll now hand it over to our presenter for today.
Hello, everybody. How are you? Let me just try to share my presentation, and then we're going to get started. Just a second. I lost my Zoom. Okay, so hopefully everybody is able to see my screen.
Yep, we can see it.
Perfect. So thank you very much for joining my presentation, and hopefully we'll have a lot of time at the end of this short presentation for a lot of questions and hopefully a lot of discussion on different topics. So as mentioned before, my title for the presentation is Polyparadigm Competency-focused Learning in Online Mathematics Curriculum. And basically, after the pleasantries, I want to explain what this is about. Pleasantries meaning, introducing myself for a second. My name is Pascal Rubides. As announced earlier, my background is quite diverse in applied mathematics and mathematical physics, as well as engineering, but also in instructional design and technology. So I'm a full-time professor at Broward College online, and I have been teaching online or been involved in online education for over 20 years. Over the time of my tenure as a professor or as an academic, I have done a lot of research on different topics, and most recently, probably the last decade or so, or even more than that, exclusively in the field of online education and e-learning. And basically, this is why my presentation is about online education. So just to proceed about what this is about, I'll give you a short sort of an executive summary of what this project is and what this presentation is going to be about. And mainly the presentation is just some preliminary results that emanate from just a small research grant. It's a project, really a research project. And the reason why I got involved in this project is because I was trying to find if there is any evidence of differences in academic performance between different courses that we offer at our college online, and that may be definitely extended to other colleges or other courses as well. This particular research project was to try to find differences, or if there are any differences, in student performance between two types of courses. One was a traditional college algebra course that we have been offering for many, many years, and that was based on publisher software such as ALEKS in this scenario, versus a different type of course. I'm sorry, the same course but a different type of delivery of the course, which was based on a sort of polyparadigm base. So the model for that was having a delivery that was structured around what I would call a hybrid competency-based learning approach. And I will mention a few more details about this. So I know it's a big word, it's a fancy word, but really it means a mishmash of different things different ideas that we have found that are useful to students, and that may also work in terms of the metrics that we're trying to assess. So the two courses or the types of courses that were being compared during this small research was a traditional online course. This was 8-week terms for all courses that we have compared. The traditional course that we have had at our college was based on ALEKS. I think now it has changed for some reasons. So basically, we have a lot of data over the time of many, many semesters about how students performed using that particular delivery. All the courses are pretty much the same. So whether you teach, the same course by different professors, or even across different terms, chances are the results or academic success, for example, or retention, may be about the same. So that gives us a lot of background information that we can draw from and compare what we would call the experimental type of delivery. So the experimental type of course that we have available, it was, again, an 8-week term, so it has to be the same, but it was mostly competency focused. It was also an OER design, and it was also contextualized. So there has been a lot of work in our college over the past maybe 5 to 10 years. Initially, we had focused on designing a lot of OER courses for different reasons. One of them was the affordability. We know with the cost of textbooks and other materials skyrocketing over the last 10 or 20 or 30 years, it was important to have students who do not have to worry about how to pay for the software that they had to use, whether that was ALEKS or something else. So we did a lot of OER courses, and in math as well, and also in other disciplines. At some point in time, we had also received a grant to try to contextualize courses. And that means basically trying to find different types of problems that are more related to a student's majors and to students' everyday lives. Even though some of the traditional courses or textbooks in mathematics or other disciplines may have a lot of different examples in different areas, however, a lot of them seem to be exactly the same from year to year and from publisher to publisher. So if somebody was in nursing, for instance, perhaps they never had seen a problem or an assignment that had to do with something specific to what they're studying. Or maybe somebody else was in construction management, maybe also they've never seen something related to what they've been studying in school. So because we have done a lot of such work before from previous grants, so I decided to use some of those assignments that are contextualized and and use those as part of the assessment process for the course. So as I mentioned, it just included a lot of different ideas. And one thing that I need to share here, I'm trying to make the course more competency focused because I have found out over time that using this constructive approach of trying to engage students and make them speak, even though a lot of them are introverts and they might not want to speak, and of course online we talk about discussion boards, and my own personal experience of having students tell me, well, every time I take the same course, the discussions are worth less and less and less, but the work is the same or more. So what's the point of me doing that? So a lot of students would actually prefer to skip, take a hit on their grade, and focus on really learn the skills. And that's one of the things I try to do here. So remove some of those extra constructive type of approaches and just try to focus more on developing the skill, mathematics skills, and assessing those skills and see what happens. So just to recap here what my research question was, it might be a little bit long to read, but just bear with me. We're basically trying to figure out if the online college algebra curriculum at my institution, which happens to be a very large state college in the south of the United States, Broward College, I don't have to hide it now, but we deliver it via a Polyparadigm competency-focused model. It's an online course, fully online course. There's no real live sessions, just an asynchronous online course. So can this type of course produce statistically significant improvement in retention and success of our students against the current type of delivery of the same course, which, as I mentioned, was based on ALEKS? So that's what we're trying to do. So in general, this type of research was just an experimental quantitative study, since it's math, definitely quantitative. And then the two metrics that we decided to try to assess and try to compare to see if there are any differences will be the normal metrics that everybody talks about, and usually those are the retention and the successful course completion of the students. I believe in many colleges and universities around the country, if not the world. For some reason, we just only assume grades of A, B, and C to be success, and grades of D or F to be no failure. So these are the two variables we are looking at. And just I'm just going to give you a summary of the results and to see if we can figure out what may have been learned from this type of research. But this is just one of many types of research projects I've engaged in over time. It's one of probably the simplest ones because there was a lack of time to do any more. And frankly, this study is supposed to be still underway. We only had one semester worth of data. And this is basically what happened. So we have found some information from this one course in the spring of 2022, so it's mostly recent. And usually we don't try to involve summer courses because the population during the summer terms, at least in my institution, is quite a bit different. So we have a lot of dual enrollment students, we have foreign students, we have students from a lot of other colleges and universities. So the population is definitely different during the summer. So what we usually do when we do this type of research project, we are looking at fall and spring and try to compare any difference between those two types of semesters. And sometimes or most of the time we'll leave summer out. So in this particular section of the course, we had 35 students enrolled, and that is the maximum of the particular course, the maximum allowable for the course. So it was maxed. And then we just measured how many students successfully completed the course. So we had 21 students out of 35 who received grades of A, B, or C. And as a proportion, that's 60%, which is quite significant given that most of the time we get rates around 40%, trying to hit 50% sometimes. So 60% was considered already significant to have. We had 5 students who did not meet that metric. So they got grades of D and F. That is a proportion of a little over 14% of the class population. And then we had 9 students who dropped the course. So they got a withdrawal, a W. And that is a metric that we use for retention. So our retention, it was dropping, so we had 26 left. So that's an equivalent of 74.3% of retention, which is also not bad at all. Okay, so this is just what happened from the experimental group, the one that we used this new particular model, hybrid, OER / competency-focused / non-constructivist. And these are the data from the past year between spring and fall. We had a lot of data for the traditional course based on ALEKS. So that's my control group data that I'm going to show you here. So out of this group of data, we have a total of 276 enrolled in those types of college algebra courses. And we see that out of those 276, 130 completed the course successfully, receiving grades A, B, and C. And that represents a proportion of 47%. As I mentioned, a lot of times people are trying to hit 50%. Oh my God, this is amazing. So we're looking at data that show something maybe even better than that 50% that we're trying to get to. We also had quite a few students who received grades of D and F. 65 students out of 276 received grades of D and F or F. And that represents almost a quarter, about 23.6% of the entirety of the students enrolled in that class. And very interestingly enough, we had 71 students out of 276 who withdrew for one reason or another, and that translates to a retention rate of exactly 74.3%, exactly just like the experimental group, where we had 74.3% retention rate. This happened, so it's very interesting how numbers come out sometimes. So already by looking at those two, this is raw data. This is not anything statistically done yet. This is just the raw data. Just looking at the proportion of students who completed successfully the experimental group. We see that we had, even in the graph, you can tell there's what seems to be a significant change. In terms of numbers, we had 60% success rates in the experimental delivery versus 47% in the traditional delivery of the course. But again, this is just raw data, so we can't really make any conclusion from that. It just looks nice, so far. Now the proportion of the W's, as noted, it was exactly the same, 74.3% for both the experimental group and the control group of 276 students. So far everything looks nice, but of course we know that we have to prove what we are seeing, even though I would like to have 60% success rate in any of my classes, or more, of course. Hopefully, or ideally, it should be 100%. But then we have to look at the data to make sure that when we draw any conclusion is statistically also uh, evident. So what I did here is very small analysis. We did a two-sample proportion test. It's basically a z-test because of the numbers of data that we have. So we have the hypothesis testing that we try to assess whether the difference between the proportion, the success proportion between the two groups was zero or not zero. And this is just a formula. I'm not going to go over that, of course. Uh, so I don't know who's exactly in this in the audience right now. So many of you may be statisticians, so you are very familiar with those. But regardless, this is a very simple test that can be done online with any free tools or even fancy calculators, Excel or any other type of software. So it's a very easy test to do. So we did the stats. So we just really simply analyze that, and I said very easy test to do. You can do it in a few minutes. You can do it by hand if you have to. So we are looking at the two samples and the z-test for the proportion of those two. And we just noted here in red, you can see we can just look at the p-value of the test, which is a 95% level test. So we look at the p-value, and it's actually quite high, 0.15. So we know that because the z-value is quite high, much higher than the 0.05 or 95% confidence interval test that we're looking for, we must reject the hypothesis. And this is another look at what we're seeing. This is a 95% confidence interval plot for the success rates and the difference between the two groups. And we can see that the two proportions may have some similarities there. So the mean may be within those ranges, which is true. So statistically speaking, I cannot say that the experimental delivery of the course, using all these different ideas all mashed together into this one course, was actually successful. That's what the statistics are telling me. So the null hypothesis cannot be rejected, so we cannot say anything that we can say that the experimental group was statistically better than the traditional group. And I repeated the same test, of course, at the 0.01 level of confidence or significance, just to see if that had anything to do. And unfortunately, it seems that it was the same conclusion. Okay, so we have to assume that this was not enough evidence to to draw any conclusion about the effectiveness of changing the traditional group to something more fancy. And sometimes people get sad about that, but it's not what this is about. I was happy that a lot more students passed successfully my experimental course, and I intend to do it again. But there's also something else to look at. So what we did so far was a traditional research study. So we look at how many people enrolled, how many people got an A or B or C, how many people failed, and then we just do the data and the analysis like that. But if you do a slightly different test, you'll find different results. And this is what really is important, I think, from this very small experiment. So different results were obtained when we compare two different things. When we compare the proportions of successful completers among the two groups, as opposed to based on the how many people enrolled. Okay, because as you can see here, the p-value is much smaller now. That's actually smaller than the 0.05 level of significance, which means that we can ascertain, or we can conclude that possibly the change of mode of delivery had some effect on how many people were able to complete the course and also complete the course successfully. So what I'm taking on here is something totally different that we are used to do in education. So if somebody started a course and after 1 week or 2 weeks decided not to continue and left, there's nothing we can do about that person. We know, okay, this person is going to fail. So it has nothing to do with the course, whether the course was delivered better, whether it was easier, harder, or anything like that. So we cannot really find out why students may withdraw or stop attending. This type of question is why do people drop out of school or a course has been said, in the 90s, 1900s, and in the 60s and the 70s with Tinto and all the other famous researchers and philosophers in education. So when I did this comparison, it looked like there there could possibly be a difference in how students pursue the course, how maybe they're more satisfied, and maybe that's why it may lead them to have better success. So what is the real conclusion here? It's kind of ambiguous. On one hand, we get something that says there's no difference, statistically speaking, and on the other hand, we say that if we look at this metric, now we can possibly see something that may be true. Again, this is just a very small sample. We had only a section of 35 students. It would be much nicer if I could continue this and have a lot more than that, maybe 200 or more students. And then maybe the result could be a little bit different. We do not know that. We also have some issue because like with every research or every type of research project, you might have things such as confounding variables. And those confounding variables could be a lot. For example, it could be me. I'm the researcher. I'm also the deliverer of the course. Maybe I have a vested interest of my students being more successful. Uh, so we don't know that. I can be objective. But again, I was the only one who was delivering this course. It should have been somebody else. We also could have confounding issues with the design being OER or the design being more ALEKS-like, because I try to create a course that's more competency focused, which is basically ALEKS is doing. ALEKS is a skill-based, competency-based. So maybe that also had something to do with getting or not getting the results that we were looking for. But I think one of the bigger issues that perhaps could be discussed if somebody asks something like that uh, is that our current metric of completion as a proportion of initial enrollment may not be the most accurate descriptor of true success. For me as an academic, not a financial advisor, not an administrator, I'm trying to figure out what is the most objective way to measure and assess learning. And if we can assess learning, we hope that we can assess success, because I guess the purpose of any course is maximize the learning of the students, which should translate to maximizing the success of the students. Whether it's in a course, in a program, or the entire careers. I think this is the most important thing to note here, that perhaps the traditional metric of success as a proportion of enrollment does not do a very good job capturing success of actual learning of students who are trying to learn. And with that, I'm going to just pause here. I think we're going to have plenty of time to ask questions or have a discussion about the different items that I presented to you. So with that, I'm going to stop my sharing and we can move forward to the question and answers. Thank you very much for joining me.
Go ahead and drop your questions in the Q&A module, or you feel free to put them in the chat as well. Both are available. While we wait for people to compile their questions, Pascal, do you have any closing remarks?
As a closing remark, the last thing I want to mention is paying attention to what we're actually measuring and what is the purpose of reality. As I mentioned before, my hope with this last sentence that I presented is to engage folks in a discussion about the metrics that we're using to assess student success. One student who may get a C may think that he or she is very successful. That might be the case. So for us, from the education point of view, if we are just measuring general items such as initial enrollment versus how many people got an A, B, or C, may not be a true depiction of true learning or true student success. So I think that's one of the most important items presented, presented itself during this research project.
Awesome. Thank you so much. Well, I think that's all the time we
Thank you.
have for now. Thank you, Pascal, and thank you all for attending today. If you or any of your fellow instructors are interested in presenting for our Learning and Growing webinar series, please submit your proposals to the Learning and Growing website, which I'm going to go ahead and link in the chat right now for easy access. We will be emailing you a link to the recording of this webinar once it's available, and I hope everyone has a great rest of your day. Thank you.
Thank you, everybody.
Okay, I'm going to go ahead and close out the Zoom webinar. Thank you so much for presenting today.